Bright QT. Every student matters.
Hello dear students, till now you have studied electricity, and in the last topic of electricity you must have studied that current has heating effects. That means the current can produce heat. In this chapter we will just elaborate the magnetic effects of current, that current may also produce magnetism. Now, it was Ørsted who firstly accidentally observed that the current can also produce magnetic effects, right? Now students, we will be performing the Ørsted experiment. So, by an activity, we will try to relate the Ørsted's experiment. For this, we will be requiring certain material. What material we all require are, we will be requiring a magnetic needle, a magnetic stand, we will require a thick and long insulated copper wire, we require a battery and plug key, we will requiring this switch for the current and variable resistance, which is also known by the name of rheostat. Now let us start up with the procedure. Now first of all, what we will do is, we take a magnetic needle and pivot it on its stand such that it is freely pointing towards north and south direction. Got it? Now we take a thick and long insulated copper wire and connect it to a battery through a switch and variable resistance, that is rheostat, as per the connections that we have done. Hold the wire above the magnetic needle such that the wire is parallel to the axis of the magnetic needle. Now switch on the current. It is observed that the north pole of the needle points towards the west as long as the current is flowing through the wire. Okay. Now furthermore, if the magnitude of the current is increased by decreasing the resistance, the deflection of the magnetic needle increases till the north pole of the needle points towards exact west direction. Now if the wire is held above the magnetic needle such that the current is flowing from north to south, then the north pole of the magnetic needle deflects towards the east. If the wire is held below the magnetic needle such that the current is flowing from south to north, then the north pole of the magnetic needle deflects towards the east. And if the wire is held below the magnetic needle such that the current is flowing from north to south, then the north pole of the magnetic needle deflects towards the west direction, right? So there are so many conclusions that we draw from Ørsted experiments. Number one, any conductor through which electric current flows behaves like a magnet. Second, the strength of the magnetic field depends on the current flowing through the conductor. That is, more is the amount of current, more is the strength of the magnetic field. Third, the magnetic field set up by a conductor acts at right angles to the direction of flow of current. Fourth is, the direction of motion of the magnetic needle depends upon the direction of flow of current and relative position of the conductor with respect to the magnetic needle. So these are few things we related. Now rules for determination of direction of motion of magnetic needle, there are different rules. One is Ampere swimming rule. Imagine a swimmer swimming in the direction of flow of current and always looking towards the needle such that the current enters from his feet and leaves from his head. Now the direction in which the left hand of the swimmer points gives the direction of motion of north pole of the magnetic needle, right? So we did the swimming rule, Ampere swimming rule. There is another rule, snow rule. Now the direction of motion of the north pole of magnetic needle can be found out by remembering the word snow, where the acronyms S stand for south, N for north, O for over and W for west. Thus, if the current flows from south to north over a magnetic needle, then its north pole towards west it will turn, and from the above rule it is clear that if the current flows from north to south over the magnetic needle, then its north pole will point towards the east instead of west direction. Got it? Now, these rules, the Snow rule also says that if the current flows from south to north under the magnetic needle, then the north pole will point towards the east. Now students, there are so many directions and so many things to consider in these experiments that we have done. You need to relate where exactly first of all the amount of current is flowing, whether it is from north to south or south to north, whether the wire is above the magnetic needle or below the magnetic needle. Accordingly, we will be able to relate the direction which is shown by the magnetic needle. So, please try to relate and understand the directions. Look at the video again twice, thrice, and try to pause and try to relate what exactly is being mentioned and specified.